Alright, what I want to look at here is the voltage in the generator, or BAWN. We just had Bunny. These are my two Swedish tennis players. If we've got a magnetic field north to south here, we've got the coil. I know the coil looks a little bit bigger than the actual space, but we'll go with that. What we learned in a previous video, or in a previous class, was that the voltage in here, when we rotate that loop, is going to be equal to V equals B L V. That V being the velocity. Now we can have, that's our center line. We'll call this R. Oops. And we'll call that L again. So L V. Now remember, that was for when the coil was at right angles to the field. Now you'll notice that when this coil goes vertical, the electrons in this wire, although spinning at the same velocity, will now be traveling directly with the field and no voltage would be produced. But at this position, they're at right angles to the field and we will get the full voltage. So looking at that, we've got L, we've got B, we've got the velocity, whatever that is, and we've got two of them. So the voltage is going to actually be equal to 2BLV. Now I want to make the substitution which you're well used to now, which is omega r. So this has a radial velocity, or an angular velocity, an angular velocity, and we can substitute that for B. So we can say 2 big V L omega r. So we're starting to get a little bit closer. Now, so 2LR, I think you saw from the last one, LR times 2 is area. So we can now say this is BA omega. And I think you see that we're nearly there. That was for one loop. For two loops, three loops, n loops, the voltage is going to equal BAWN. Don't know why I call it BAWNy, but so now that's all very nice and very simple, but this voltage is actually, as we just said, going to be maximum when it's at this point and minimum when it's at the top. Now we know we can characterize the angle that this little loop is spinning at, theta if you like, is equal to omega t. We learn that in SHM, and if we haven't done SHM, well, we will learn it when we do SHM. But anyway, the angle equals omega t. Now the only thing we've got to decide is whether we measure our angle from the horizontal. That means, is our angle like this, or is our angle this one from the vertical with the coil? So at this point, I want to use the sine. So we've got maximum voltage at, and to get a sine, maximum voltage, we just think about our sine curve and we go, okay, so at 90 degrees we've got a maximum sine. So I'll measure my angle from the vertical and I can then say that the voltage is equal to BA omega n sine omega t. We've now got the formula for the voltage in a spinning coil with n number of turns.